very quickly going into, now let's say that what happens when your strategies are stochastic. So we've only looked at pure strategy, the action is one or two, one of the actions as a strategy. What if my output is a mixed strategy? So let me give an example of a mixed strategy. And it's a two-finger molar, so there are two players. One is called as odd, and the other one is called as even. So odd has two options, one finger or two finger. And even also has two options, one finger or a two finger. So if odd says 1, even says 1, so sum of both of them is 3. So even gets a plus 2 and odd gets a minus 2. If odd says 2, even says 3, so even gets minus 3 and odd gets a plus 3. So the sum decides what is the score. If it's odd, odd wins. If it's even, even wins. So here even gets a minus 3. Oops. So here even gets a minus 3 and odd gets a 3, and here even gets a 2 to 4 and odd gets a minus 4. So now I need to be able to solve for this one, and there's no pure strategy that will work, so I cannot say whether whether 1 is best or 2 is best. There's no such clear strategy, and therefore I say that okay, now I need to solve and get an output which is a mixed strategy. So the mixed strategy will be something like that. Something, let's say 0.5 or 0.4 and be even. So this mixed strategy says that 40% of the time even should strike 1 and 60% of the time even should show 2 in a two-finger molar. And how do I solve this thing up? So we know if this game was sequential, first even and then odd, it was a very simple game. So let's make it sequential. Let's cheat. So the first player is, say, even. And by the way, it's a zero-sum game. 2, 3, 4, I mean, plus 2 minus 2 plus 3 minus 3. So I could only write it for one of the players. So let's say this is my first player, which is even. And it has option of action of 1 or action of 2, and based on that odd plays, and it has option of 1 or 2, and I will have the actions for the odd. Even is my match, so the action will be even. So 2 even wins, 3 even loses, 3 even loses, 4 even wins. Odd will take out the maximum with the least, which is a minus 3, and even will take out the minimum of them, which is a minus 3. Let's do it the other way around. What if I have odd play first? And then even. So 1 plus 1, 2 is even, 2 plus 3 is odd, 2 plus 3 is odd, 2 plus 2 is even. So it turns out to be a minus 3, it turns out to be a plus 4 over here, and it turns out to be a plus 2 over here, and odd is least of the two, so it's plus 2. So what this shows is that if one of them cheats, this is exactly what happens. If one of them cheats, that means one plays before the other, and whoever is the one who plays first is at a loss. In the first one, odd has cheated and it asks even to play first and then it plays based on what even plays. In the second one, even has cheated. It doesn't show its fingers, it just looks at odd and then it plays its fingers. That means what I know is that the payoff or the score has to be between -3 and 2. One when you are an idiot and your other person is a pro at cheating, looking at what you're doing, and the other one when your other person is a idiot and you are an absolute pro. So that's what's a return. Now in reality that's not what will happen. So what I do instead is that I say let even fix a strategy first. So I fix a strategy for even and I publicize it up so odd knows what is even strategy. Even this time does not reveal its fingers. It's not like even says 2 and then odd says 1. So even just reveals what is its strategy, and let's say the strategy is one with a probability of P and 2 with a probability of 1 minus P. So this is even's move. So let us solve the game, and so let's say that even plays first. So I have even here, and now I don't know which exact action has been played, a 1 or a 2, because it's coming from a random lot, and that's how I represent it, that with a probability P the action will be 1, and with a probability 1 minus P the action will be 2, and I cannot look at it because odd, which plays next, knows that even is playing with this strategy, randomly selects 1 or 2, 1 with a probability P and 2 with a probability 1 minus P, knows P, but given a game, odd now cannot look into what has even really played, and odd has to make a choice between 1 and 2. One thing that I've changed is that with even the action is stochastic. So with a probability P1 with a probability 1 minus P2. With odd I say that it's a pure strategy. So it'll select one of the two actions, and that's because even if you take it as stochastic Q times 1 and 1 minus Q times 2, you calculate both the things up. P is already known for odd, and you get it minimum of this or this with the two, with the probability Q, and one of them will turn out to be better and the stochastic one will turn out to be a weighted addition. So a weighted addition can never be better than the better of these two. So I take a pure strategy given that even strategy was known. So now really what happens is that with the probability P I would have played 1 and then I would have got 1, so even would have 1, so that would have been a 2, but then that is based on the assumption that I played 1. On the other hand, with 1 minus P I would have played 2, 2 plus 1, 3, that is odd, so the score to even will be -3, but then of course I made the assumption that I played 2, which is 1 minus P, and similarly 1 plus 2, which is a 3, so that's a -3, but I made the assumption that I played 1. If instead I would have played 2, 2 plus 2 is 4, but of course I assumed I played 1 minus P over here. So given a P, this is what the returns are, average of infinite runs, and odd would of course like to take the minimum of them, so that's the minimum of 2p minus 3, 1 minus p, and minus 3p plus 4 times 1 minus p. So let's simplify it up. So this one becomes 2p plus 3p. So this becomes 5p minus 3, and this becomes 4 minus 3 minus 4 minus 7p. And let's plot it up. So this is your p. So that's your first line. That's how it goes. And this one becomes your second line, and this one is going like this. That's how it goes. And what I need to do is that it's the minimum of this line or this line. So if you end up taking the minimum of both lines, you actually end up in getting this as a curve. So minimum of these two lines, so that's this as a curve, and this is what odd will select as a pure strategy. Now, even tries to maximize it up. So the only control with even is that it selects P, knowing all this. So what P does it select? The one which has the maximum. So what's the, I vary P like this, bad returns, slightly better, again going bad. And what is the best value of P when both of them are equal? So 5P minus 3 is equal to 4 minus 7P. Or P only, even has only one control, which is how do I select P? So that becomes 7 by 5, 7, 12. And you do it for the other way around, it also becomes the same value. So what this game is there for, that by assuming that even is playing first and revealing its strategy to odd, so even had to control the strategy parameter P, it was maximizing against all P's, and odd was controlling based on a fixed strategy whether it plays 1 or 2. The only thing is that it doesn't know whether 1 was played or 2 was played. It cannot cheat. Solving this out, we get what is the best value of P, and that's exactly what even would do. So 7 by 12 times it will select 1, and 1 minus 7 by 12 times it will select 2. So generate a random number, take a 12 faced dice, and if number 1 to 7 comes, you select 1. If numbers 8 to 12 come, you select 2. That is how you maximize this up. And of course, this also gets me towards the conclusion of this course. If you are following the book and you probably believe that I've only covered 1/3 of it up, then that's absolutely correct. In this institution, we take 2 courses in parallel. So one is AI, and of course the other is machine learning. So everything to do with uncertainties, learning, what is covered in the other course. And thereafter, we have a bouquet of options that you get in the subsequent semesters, which are lots and lots of application papers. In the application papers also, we look into some specific techniques and algorithms that I did not look at. And the other part that I absolutely did not cover is a beautiful course on soft computing. So now you've studied AI from me. You have studied machine learning, the other component, from 2 big giants. You will be studying soft computing, and of course you will be studying in all the application papers as electives from all the wonderful array of faculty. Over here, AI will not leave you till the end of the degree. However, specifically as far as the artificial intelligence lecture module is concerned, this is me finally signing off. Thank you for following it up.